Hey everyone, in this video we're going to do a couple examples of finding the limit of more complicated trig functions. So we've already established the limits of some basic trig functions, and what we want to do is use those in some trig identities and other methods to work with trig expressions, and we want to find the limits of expressions that are more complicated. Let's start off by just taking a look at the basic ones that we've already established. So we have the basic ones for sine and cosine. So the limit as x approaches 0 of the sine of x, this was equal to 0. We have the limit of cosine. So as x approaches 0 of the cosine of x, this was equal to 1. We also have the limit as x approaches 0 of the sine of x divided by x, and we saw that this was equal to 1. And directly from that, in a couple applications, we saw that we can end up with a nice result for the limit as x approaches 0. And now if we have a constant, so let's say we have a times x, and this is divided by x, we saw that this worked out to be just a. So all those are very useful, and there's one more that's going to come in handy for us, and that is the limit as x approaches 0 of the cosine of x minus 1 divided by x. And in a similar fashion as we did for the other ones, if we take a look at a graph of this function, we can convince ourselves that this is equal to 0. So with these 5 basic ones, along with our trig identities, we should be able to find the limits of more complicated trig expressions as well. So I want to do 3 examples where we're going to do that. In each one of these examples, we are going to use a slightly different method in each case. So the first one, the limit as x approaches 0 of the sine of 3x divided by x times the cosine of 4x. Now one thing we can't forget here is we do also have we have our sum, our difference, product, quotient properties that we can use with limits. So I have a little bit of division and I have some multiplication here. So the first thing I'm going to do is I'm going to split this up into 2 different limits. So we will have the limit as x approaches 0, and then in this first one I'm going to do the sine of 3x divided by x, and then I'm going to multiply by a second limit. Again, this is going to be as x approaches 0. And if I sort of factor out this first piece, what I'm going to be left with is 1 over the cosine of 4x. And now written like this, it's much more manageable. So this first limit, this is one of the results we saw earlier. So the sine of 3x divided by x, this is going to work out to be just 3. And then times, we still have our second one here. Now our second limit, I have 1 divided by the cosine of 4x. But if I think about that value of 0, that is in the domain of this function, right? If I plug in 0 to cosine, I just get a value of 1. So this will work out. So we can just evaluate this by plugging in 0. So 1 over the cosine of 4 times 0. So here we have 3, and then this is going to be 1 over the cosine of 0. And like I said, the cosine of 0 is just 1. So we get 3 times 1, which is just 3. So going back up to our original, the limit of this entire thing is equal to 3. So in this example, it's just important to know that it's already in sine and cosine, so we can't really use our trig identities with it, but if we separate it into a couple pieces, maybe it's easier to work with. All right, let's move on to the second one. So here the limit as x approaches 0 of 2x times the cosecant squared of x plus the cosecant of x, and this is divided by x times the cosecant squared of x. Okay, there's quite a bit going on here. But I do see right away it's all cosecant. So why don't we try separating this and see if we can simplify. And when I say separate, I just want to split this up into two different fractions. So the limit as x approaches 0, and then just on the inside here, I'm going to rewrite this as two fractions. So they're both going to be over that common denominator. So this will be divided by x cosecant squared of x. And then we'll split this off. So plus cosecant of x divided by x cosecant squared of x. Okay, so now we can simplify these fractions. So we still have the limit that we're looking at as x approaches 0. This first fraction, we have a lot that simplifies. I have an x in the numerator, an x in the denominator, cosecant squared of x, cosecant squared of x. So all of that will simplify, and I'm just left with 2. So that works out really nice. In the second fraction, I have a cosecant of x to the first power, and in the denominator, I have a cosecant of x to the second power. So one of those will simplify. And that's just going to leave me with 1 over x times the cosecant of x. So I know what to do with 2, but the second fraction, I can actually work with this a little bit more. So I know that cosecant of x, that's the same as 1 divided by the sine of x. And if I'm dividing by a fraction, it's the same as multiplying by the reciprocal. So what I end up with, so we still have 2, but now switching this to 1 divided by sine, and then we can multiply by the reciprocal, we end up with the sine of x over x. So with a little bit of simplifying, we now have a sum, and we can split this up into the sum of two limits. So we have the limit as x approaches 0 of just 2 plus the limit as x approaches 0 of the sine of x divided by x. And this worked out really nice because both of those limits we know how to handle. The first one, the limit of a constant, is always just the constant. So that first one is just 2 plus the second one, that's one of the ones we established in the beginning. So the limit as x approaches 0 of the sine of x divided by x, we know that's 1. And altogether then, this is equal to 3. So this entire limit up here, our solution is 3. So in this case, it looks like we have a lot going on, but we noticed that it was all cosecant. So the first thing we wanted to try is how much can we simplify? And then after we simplified a little bit, then I rewrote cosecant in terms of sine to help me out. And that made it pretty straightforward to find our limit. Let's take a look at one more. The limit as x approaches 0 of the cotangent of x minus the cosecant of x, and that whole thing is times the sine of x, and then this is divided by x. So in this case, there's not much we can simplify, but what we can do is we can rewrite everything in terms of sine and cosine. So let's start with that. So we still have our limit out front, and now we're going to rewrite this all in terms of sine and cosine. So cotangent, that's equal to the cosine divided by the sine. And then cosecant is 1 divided by sine. And these are still in parentheses here. We're multiplying by the sine of x. And then this is all over the x in the denominator. So these two fractions I end up with, they do have a common denominator of sine of x, so we can bring those together. So that's going to give us the cosine of x minus 1 over sine of x. And then this is multiplied by the sine of x, which, now that I'm looking at it, is actually going to work out really nice. We have a sine of x in the numerator. We have a sine of x in the denominator, so that will simplify. And now what I'm left with, I have the limit as x approaches 0 of cosine of x minus 1 divided by x. And again, that's one of the ones we established in the beginning. So we know that this has a value of 0. So going back up to the original, the limit of this entire thing, this is equal to 0. So in this final example here, there was not much we could simplify from the beginning, but we were able to rewrite everything in terms of sine and cosine, and then we were able to simplify a lot. So 3 different examples using 3 slightly different methods, but each of those methods are really important to keep in mind so we can find the limit of more complicated trig expressions like this. Thanks.